Hey everyone, I am back with Math of the Day. Maybe that's what I should call my channel. Math of the Day. No? Okay, I won't. Alright, so we did products of square roots a little bit ago, and now we're just going to kind of elaborate a little bit more. So what we did before is we took a number and we broke it up so that we could simplify. Okay, now what we're going to do is we are going to take two numbers that are broken up and put them together in order to simplify. So let me explain. If we took the square root of 18, we know the square root of 9, so we made that into 9 times 2, and so we could get 3 times the square root of 2. Now we're going backwards. If we have the square root of 2 times the square root of 3, we can multiply and get the square root of 6. But this is why it matters, because the square root of 8 times the square root of 2, that would be the square root of 16, which simplifies to 4. So it's just going backwards, just so you know. I'm going to skip right to example 3 because 1 and 2 are a little bit crazy with graphs, and I'm going to do those later, but this is like the easiest one to start with. So the square root of 3 times the square root of 12 is the same as the square root of 36, which easily simplifies to 6. So this is the easy peasy one. B is a little bit different, where we do the whole tree and everything. Okay, so we have the square root of 42 times 24. So don't even multiply those numbers, just do the two separate trees. So we got 6 and 7, and I did this all, and we ended up with 2 times 2 times 2 times 2 times 3 times 3 times 7, okay? And remember, look for pairs. Some of you were looking for pairs, but then you weren't making them 1. So these two 2's become 1, 2. These two, and so on and so forth. And 7 is left under the radical. So remember, we take pairs and we make them 1 outside of the square root, okay? So 2 times 2 times 3 is 12, and then times the square root of 7, because that didn't change, because it didn't have a pair. Okay, so this is the first, this is like the easy portion of it, and then we can jump into, well, there's one more example, so I'll relax for a second. Here it is, up close and personal. We have, this is letter C, 3 times the square root of 6 times the square root of 15. Okay, so what they did is 3 times 2, 3 times 5. Okay, so really we have 3 times the square root of 2 times 3 times 3 times 5. I'm in the habit of putting them in number order, which I think is the best thing to do. Only one pair, so bring it to the outside, it becomes just 1 3, so it becomes 3 times 3 times the square root of 2 times 5, which is 9 times the square root of 10. Okay, so don't let it, if there's already a whole number, just leave it as a whole number all the way throughout. You just have to worry about simplifying the square roots. Okay, so 9 times the square root of 10. Now let's jump into the ugly ones. And I'm hoping this works. This is what the example is in your book. I'm hoping you're looking at the book, but you're also seeing this as well. They kind of barely say that we use the Pythagorean theorem to find the sides. Well, here's what they did. You see how this is a slant? They created a triangle so they could use the Pythagorean theorem. So the sides are 3 and 3, and you're looking for the hypotenuse. So 3 squared plus 3 squared equals whatever the hypotenuse is. So this ends up being 9 plus 9 equals 18. Well, I'm going to say c squared. 18 equals c squared. So c is the square root of 18. Only we're just going to leave it as square roots because that's what we're dealing with right now. And then they did that for the smaller side too. And they saw that this is 2 and 2. So they used the exact same thing with Pythagorean's theorem to find this side, because this is a rectangle, so these are 2 different lengths. Hopefully that helps you see how they did that. So we figured out that the first side was the square root of 18. The second side, if you see, like, look at your book. I'm just showing you how they did it. These are 2 and 2, so in order to find the smaller side, we use 2 and 2 to find c. So 2 squared plus 2 squared equals c squared, and we end up finding out that c is the square root of 8. And because we're working with square roots, it makes total sense to leave it as square roots. Now, they actually want area, length times width. One side is square root of 18, one side is square root of 8. So multiply them. And if you do 18 times 8 on your calculator, you get 144, which is very convenient because we know that square root is 12. So it ends up being 12 units squared as the area. So that's example A, or example 1. That's how they did it. They used the Pythagorean theorem to find how long those sides were, and then they were able to find the area by multiplying those two square roots. All right, let's go to example 2. Take a look. I think it's pretty easy once you know how to do it. Example 2 is a little bit different. They have a big square and then a small square kind of tilted on the inside. So the big square, it's easy to find the area because 1, 2, 3, 4, 5, it's 5 by 5. So that ends up being 25 units squared. Okay, that's pretty easy. But to find this other one, we once again have to use the Pythagorean theorem. So the sides that we use are 2 and 3 in order to find the slant. So 2 squared plus 3 squared equals c squared. And that's what I'm going to do. And that ends up being 4 plus 9. That ends up being the square root of 13. Okay, so that's just the side, not the area. Area is side times side. So the square root of 13, remember if we did like this, the square root of 13 times the square root of 13 would end up just being 13 if we take it outside. Okay, so the area of the first is 13 units squared and the big one is 25 units squared. So they said, and this is PQ, I think, PQRS, and this is ABCD. Okay, they say the area of PQRS, which is 13, is equals what percent, I'm going to put a P, of multiply the area of ABCD. So what I did, this is the easiest way for me to do it because this is how I think. I think of it as an equation. Area equals percent of area. So I just plug in the numbers. And then I can divide by 25 to find the percent. And I did not do that, so I'm going to look at the book. 13 divided by 25, you end up with 52%. You're probably going to end up with 0.52. Be smart. 52%. Also, you could have done this. 13 over 25 equals what over 100? And then times 4 times 4. Because percent is always over 100. So how you solve it or how you simplify it is up to you. Okay, you could also do small over big to find the percent and just skip to this fraction. You can see that in the book. They did that as well. But to me, it's always easiest to just write it out as an equation based on the question. All right, so we already did example 3. This is as hard as it's going to get with the pictures and the graphs. Just count the units and use your Pythagorean theorem. By the way, Pythagoras created the Pythagorean theorem. I honestly thought that was going to be like an easy one for all of you to get on the test. I was trying to like give you more points. If you got it wrong, just now you know Pythagoras is where we got Pythagorean from. All right, you guys have a great day. If you need anything, please comment, let me know. And if it comes down to it, I don't even mind if you guys end up having to call me or whatever because that's what I'm here for. All right, see you later, hopefully.